Hello everyone. You're welcome back to trigonometric function. So we're going to look at quadratic trigonometry equations today. All right. So let's look at an example here. So this example says solve each equation for x in the interval 0 less or equal to x less or equal to 2 pi. All right, now this is the first one. Sine square x, sine x square x minus sine x equals to 2. Another one is b. Another one is 2 sine square x minus 3 sine x plus 1 equals to 0. Another one is the third one is 2 sine square x minus 3 sine x plus 1 equals to 0. All right, so now let's solve these three quadratic equations. All right, so solution. Don't forget in our previous class about the trig ratios. All right, so because it will help us, those trig ratios, trig functions are the basic trig identities we must know in order to be able to solve these trig equations, trigonometric equations. All right, so number one, let's get to it fast. Number one, sine square x minus sine x equals to 2. Now, we write this equation as sine square x minus sine x minus 2 equals to 0. Now, there's something here that is common. All the sine, use it to represent the letter. So as to simplify it. Now, don't forget something here. Sine square x is the same thing as sine x, everything all squared. All right, so this is sine x all squared minus sine x minus 2 equals to 0. So you say let sine x equals to p. All right, so we substitute here. So we have p squared minus p minus 2 equals to 0. So we'll now factorize this expression. All right, so my favorite method, the first times the last one, minus 2 times p squared, that's minus 2p squared. So what are the factors of minus 2p squared? We have minus 2p plus 1p, yes. Minus 2p, then plus p. Because minus 2p times p will give us minus 2p squared, then minus 2p plus p will give us minus p. So replace this with this. So we have p squared minus 2p plus p minus 2 equals to 0. So we'll factorize. So this is p into p minus 2 plus, what's common? The fact is 1. 1 is a common factor. So minus 2 equals to 0. All right, so p, this p, then plus 1, and p minus 2 equals to 0. So p plus 1 equals to 0, or p minus 2 equals to 0. So further solve it as p equals to minus 1 or p equals to 2. So now don't forget our statement sine x equals to p, and our p is minus 1 or p equals to 2. So we'll now substitute each one of them. So we start with the first one. When p equals to minus 1, so we have sine x equals to minus 1. All right. So how do we now find x? Because it's an x. So we divide both sides by sine. All right. So when we divide both sides by sine, so it will remain x here. So we have arc sine or inverse of sine minus 1. All right. We have inverse of sine of minus 1. All right. So arc sine 1 is minus 90. Minus 90 degrees. All right. So now when p equals to 2, all right, so sine x equals to 2. The same thing, x, we'll find the inverse, equals to arc sine of 2. All right, so arc sine 2. So this one has no solution. No solution. All right. So let's go to the second example. So the second example, 2 sine square x minus 3 sine x plus 1 equals to 0. Same thing. Don't forget I said sine square x is the same thing as this. All right, so this is 2 sine x all square minus 3 sine x plus 1 equals to 0. So let sine x equals to, use any letter of your choice. So I'm using m. So this is 2m squared minus 3m plus 1 equals to 0. So we factorize it. So 2m squared times 1, the first and the last, so that's 2m squared. So what's the factor? The factors are 2m and m. So 2m minus 2m minus m. Because minus 2m times minus m will give us 2m squared, and minus 2m minus m will give us minus 3m. So we replace it, we replace this term. So we have 2m squared minus 2m minus m plus 1 equals to 0. So we factorize it. So we have m into 2m minus, no, 2 is actually, sorry, there's a mistake here. The common factor here is actually 2 is also common, m is also common. So what do we have left here? M, then minus 1. So minus, what's common here is 1, just 1. 1 plus 1, sorry, minus, because we factorize minus here, minus 1 out. So it will be minus. It's because you have to watch out for these terms in the bracket. It must be the same. Because then, so we have this 2m minus 1 and m minus 1 equals to 0. So 2m minus 1 equals to 0, or m minus 1 equals to 0. So 2m equals to 1 or m equals to minus 1. So m equals to 1 over 2 or m equals to minus 1. So we'll go back to our statement from where we say let sine x equals to m. So now for the first one, when m equals to 1 over 2, so we have sine x equals to 1 over 2. So x equals to arc sine of 1 over 2. And that is arc sine of 1 over 2 is 30 degrees. All right. So let's go to the second one. When m equals to minus 1. So sine x equals to minus 1. So x equals to arc sine of minus 1. So x equals to minus 90. Minus 90 degrees. All right, so let's take another example. 2 sec square x minus 3 plus tan x equals to 0. All right. Now, this time around, we must remember our trig identity. Don't forget that this sec square x, we must write this sec square x in terms of tan x. So now when we remember one of our trig identity, we have, from one of our trig identity, we have 1 plus tan square x equals to sec square x. All right, using Pythagorean identity. All right. So the goal is to create an equation with only tan x. You understand? With only tan x. So we must change this thing to change this equation so that it will only have tan x. So we must simplify this. And here, in one of our trig functions, we have Pythagorean trig identity. We have this. So sec square x is equal to this. So we'll substitute this value for this value here. So we have 2 into 1 plus tan square x plus, minus 3 plus tan x equals to 0. It's minus, sorry. So we open the bracket. This is 2 plus tan square x minus 3 plus, 2. Then 2 times tan square x is 2. Then plus minus 3 plus tan x equals to 0. So now it's taking the shape of a quadratic equation. So let's tidy it up. So we have 2 tan square x plus tan x. Then what is 2? This is minus 3. This is minus 1. Because 0. So 2 minus 3 minus 1. So we have, so let tan x equals to n. All right. Just as we've been doing. So we have, don't forget, this is 2. Then this one, don't forget, this one is same thing as tan x all squared plus tan x minus 1 equals to 0. So this is 2n squared plus n minus 1 equals to 0. So this is, so we factorize. So the first term, 2n squared times minus 1, that's minus 2n squared. So what are the factors? And the factors are, and what they must give us plus n. So we have plus 2n, then minus n, because plus 2n times minus n is minus 2n squared, and then plus 2n minus n. So this gives us plus n. So we'll replace this. So this is 2. We replace this with this. So we have 2n squared plus 2n minus n minus 1 equals to 0. So what's common here? 2 is common. N is also common. So broken bracket. So what's left here? N, then plus 1. N plus 1, then minus. Then what's common here? 1 is also common. So we factorize minus out. So we have n plus 1 equals to 0. So we have 2n minus 1 into bracket n plus 1 equals to 0. So at the end of the day, we have 2n minus 1 equals to 0, or n plus 1 equals to 0. So 2n minus 1, let's solve this part. So 2n equals to 1, or n equals to minus 1. So n equals to 1 over 2, or n equals to minus 1. So let's go back to our statement. We said our tan x equals to n. So the first one, when n equals to 1 over 2, tan x equals to 1 over 2. So x equals to arctan of 1 over 2. All right. So what is arctan of 1 over 2? Arctan of 1 over 2 is that's at 26.56 degrees. So then second one, when n equals to minus 1, we have tan x equals to minus 1. So x equals to arctan of minus 1. So we have arctan of minus 1 is going to give us minus 45 degrees. So thank you so much, guys. Please watch this video and rewatch it. Like and share it with your colleagues. And I'm open to asking questions for if you want me to re-explain or to solve other examples. Thank you very much.